Okay, so this is a SYN flooding attack. So how do you defend against SYN flooding? There's some interesting defenses out there. The first defense that might occur to you is to buy lots of memory. Memory's cheap. And it seems reasonable, but you kind of got to work the math to figure out how this is going to work, because the target has to, you know, how long is it going to keep around the memory associated with a connection until it times out? Maybe a few minutes. How much memory per connection? Maybe 100 or a few hundred bytes. Multiply how many connections per minute can the attacker make, and then you got to figure out how much memory you're going to need. So this may or may not be suitable. Could we limit the number of total connections for each IP address? Oh, that's interesting. So using some kind of quota, like each IP address gets to make at most 3 new connections per minute. A natural idea. Unfortunately, that's not effective, because remember how the attacker needs to send only a SYN packet? The attacker only needs to send a SYN packet. That means the attacker can use a spoofed IP address, a spoofed source address in that SYN packet. And each SYN packet can have its own source IP address. So the attacker can send 100,000 of these SYN packets, each with a different spoofed source IP address. And every one of those is going to be under the limit. So limiting per IP address actually does not help because of the possibility of spoofing. Could a target evict based on whether an ACK was received? Yes, that would be possible. That'd be possible. Yeah, so for pending connections where you have not yet received an ACK, evict those first. That's reasonable. What would an attacker do if we adopted that defense? Maybe the attacker would send the ACK, so now the attacker has to send both a SYN and an ACK. But it's interesting. I hadn't thought about that one. That's a clever idea. A second approach we could imagine would be to try to identify who are the ones who are doing SYN flooding. But as I just mentioned, that doesn't work. That's not an effective defense because the source IP address can be spoofed. Okay. So third approach that I wanted to teach you about is a really clever one that I think is just so cool. It's just such a clever idea that's deployed today. It's called SYN cookies. And the idea is the attacker cannot exhaust our available memory if we don't use any memory. Kind of a tautological vacuous statement. So in this approach, what we're going to try to do is avoid keeping any state on the server, any per connection state. Now, we're not actually going to be able to avoid keeping any connection on the server per connection. We're not going to be able to avoid any per connection state, but what we're going to be able to do is to make sure we don't need any memory while the three-way handshake is in progress. So after the three-way handshake finishes, maybe we'll use some memory, but before then, there'll be no memory consumed by the server per connection, okay? So the basic idea of this defense, let me show you what it would look like if we got to redesign TCP. Remember how the three-way handshake works is the client sends a SYN, the server sends back a SYN ACK, and here what we could do is instead of having the server keep some state in memory, it could stick that in the SYN ACK packet and send it to the client, say, hey, here's some stuff I want to remember. Can you send it back to me when you send me back the ACK packet? And then when the client sends the ACK packet, the client could be in charge of responding with that state. And then the server could save the state after it receives the third packet in the three-way handshake. So that way the server doesn't need to keep any state until the three-way handshake completes. When the three-way handshake completes, we know that the source IP addresses were not spoofed. So now we could save state, and then we could do per IP address limiting of the number of connections per client, and then we wouldn't have to worry about spoofing. So this would be a very natural approach if we could redesign TCP. But unfortunately, the SYN flooding attack was discovered after the TCP protocol was already invented and widely deployed. So you can't do this. It's actually not possible in today's TCP. There is no header field where the server could stick some state and require that the server respond with it. Okay. So unfortunately, deployment with this is a problem. So the really clever part about SYN cookies is that SYN cookies found a way to do this without having to change the protocol and without having to change TCP clients. So the idea is we don't create state after receiving the SYN. We'd like to return the state in the SYN-ACK packet. And what we're going to do is, instead of putting in another field, we're going to encode it in the sequence number. The server has a choice of the sequence number, and the server is going to choose a sequence number that encodes the state into that 32-bit sequence number. There's not room for very much state. There's only, less than 32 bits at most, but hopefully that'll be enough. Okay. So we put all of the connection state encoded in the server's initial sequence number, and then what this is just like the state, like a timestamp, and then there's a HMAC, a message authentication code that's applied to it, so that when the state is returned, the server can verify that it hasn't been tampered with, check the value of the HMAC, and then use the state in Y+1 in the ACK to actually use some memory for that. Okay, so SYN cookies are a really clever idea to defend against memory exhaustion due to the SYN attack. Now, this has nothing to do with amplification. SYN flooding has nothing to do with amplification. There is no amplification. In SYN flooding, there's no patsy. We're not trying to flood someone else. SYN flooding is about using up memory on the server, and SYN cookies is a way to make sure that no memory is used until the connection has been established and we know it wasn't a spoofed source IP address. Okay, so this is a general strategy that you can look for whenever you want to defend against memory exhaustion attacks, rather than using state, creating holding state on the machine, encode it and send it back to the other party so that they'll be returned when you need it.